ways to configure static route, or you can consider it as a type of static routes. Okay. The first one is known as recursive static route. Okay. So how do you configure a recursive static route? Command will remain same. You will say IP route. Okay. Then you're going to give here the network. Means this will be your destination network to which network you want to reach. Then after you'll give the subnet mask. And then finally you're going to give the next hop address. This thing we configured yesterday. Correct? Okay. Let's configure it again. So I'll simply take two routers. This one I'll call it as R1. This one I'll call it as R2. Between R1 and R2, I'll use the network 192.168.12.0/24. And this side I'll use few loopbacks 10.1.1.0/24, 20.1.1.0/24. (30.1.1.0/24). Okay. These are the network we are going to use. Then the IP addresses here on R1, all the IPs will be .1. And on R2, all the IPs will be .2. Okay. Like 12.2, then you can say 10.1.1.2, 21.1.2, 31.1.2, like that. Okay. So one way is I can just go and configure the routers, right? Let me tell you easily. Okay. What you do, you open Notepad. Okay. Then after, let's say, first of all, I want to do the configuration for R1. What will be the commands I will be executing on R1? First command would be enable, then configure terminal. Then let's change the hostname also. Let's say R1. So hostname, in short, I'll just say host. Okay. Then interface 0x0, IP address 12.1.255.255.255.0. Correct. And then I'll give no shutdown. Done. This is all the configuration I'll do on R1. If I want to configure R2, what will be the configuration for R2? This will become R2. Hostname will change. Interface is same. IP address will become 12.2. Then I have some loopbacks. So interface loopback 1. IP address 10.1.1.2. 255.255.255.0. Do I need to give no shutdown? No, because this is a logical interface. Let me copy this, and I have 3, so I'll paste it 3 times. This will become loopback 2. This will be 20. Loopback 3. 30. That's it. Correct. See, when you use Notepad, configuration becomes easy. You can just go and copy paste. Second thing, you have backup of the configuration. In case if you by mistake restart the router, close the packet tracer also, next day you want to perform the lab. So still you have this configuration. Next day you just need to copy and paste. Okay. Otherwise, if you're not taking backup like this, or if you're not doing it in the notepad, what will happen? Next day, all the comments you have to type in again, right? Now, how do you copy? Simply just select it all, copy, done. Go to your router, CLI. First of all, here, say no. Because enable command, you will type in the which mode? User execution mode. So right now we are in the user execution mode. So either you right click here and click on paste, or already there is a paste button. Done. R1 configuration is done. Same on the R2. Just copy the configuration. Just make sure you copy 1 or 2 lines extra, because you have to hit enter also, right? Copy. Go to R2. CLI. Say no. And then paste. Done. You can check. All the configuration has been done. Now, since all the configuration has been done, you can check. Do show IP interface brief. See, all the IPs are set. Loopback 1, 2, 3 and gigabit Ethernet 0, and host name is R2. Same thing on R1 is there. All the IP addresses are set, host name are set. Correct? Okay. Now, what we have to do, we have to define a route, because R1 doesn't know about 10, 20, and 30, right? So if I want to define a route, how I'll define? I'll say IP route. Then which network I want to reach? 10.1.1.0. This is my destination network. Subnet mask would be 255.255.255.0, and next stop would be 12.2. 12.2. Done. Check. Do show IP route. Route is there. There is a route. Okay. Now what? If there is a route, that means I should be able to ping. So do ping 10.1.1.2. And I have the connectivity, you can see, I can ping, right? This routing seems fine, but there is a problem with this route. What is the problem? See. The problem with this type of route is this is your static route. What it is saying, that if you want to reach 10.1.1.0, you can reach via. This is the first time your router will check the routing table. This is known as the first lookup for next stop. For next stop address. Router will check the routings. Like, let's say you have given the ping command, then you have generated a packet for 10 here. Once you have generated the packet, router will check the routing table, how to reach the 10 network. Correct? It will see, okay, I can reach via 12.2. So this is the first time your router will check the routing table. Then it will think, how do I reach 12.2? Because this is still IP, and router will forward packets from one interface to another interface. It will take packets from one interface and forward it on the other interface. So still we do not have on which interface router has to send the packets. So router will check second time. That will be your second lookup. The second lookup will be for exit interface, that through which interface it will exit. So it will check, how do I reach 12.2? Okay, I have a 12.0 network entry, and I can reach via gigabit Ethernet 00. So your router has to check that routing table twice for each and every packet. For each and every packet, router will check the routing table twice. So the second lookup will be for exit interface, that through which interface your traffic is going to exit the router. So 2 times your router is checking the routing table, right? Now you can imagine the amount of traffic in the companies that is generated. right? So if router will check the routing table twice for each and every packet, how much CPU router is going to use for forwarding all the packets? Means there will be high CPU uses. Okay. And this situation, when your router is looking up the looking the routing table twice, this is known as recursive lookup. This is known as recursive lookup, and that's why this type of static route is known as recursive static route. Is that clear? So what is the problem? Router is checking up the routing table twice for forwarding each and every packet. First lookup for next hop address and second time for exit interface. This is clear? Okay. Then how do we avoid this? So if we see ultimately what your router wants, that I need to know the interface. So instead of giving the next hop address, if I directly give the exit interface, then what? Router will directly forward. Router will not check up the routing table twice. Correct? Okay. Now, this is clear about. Okay. So here we have a disadvantage, and that is your recursive lookup. Recursive lookup is a disadvantage. Okay. So we came across the second type, and that is your directly connected static route. How do you configure a directly connected static route? Instead of next hop, we will give exit interface, and the rest of the command will remain same. To which network you want to reach? What is the destination subnet mask? And then what will be the exit interface? So exit interface is yes, because it will consider directly connected. Okay. Now we will use this format to configure a static route. Okay. So right now, if you check from R1, will I be able to reach 20 network? No. Why? Because no route. If you see here, only route is there for 10, no route for 20. Check. Do show IP route. Only for 10 we have a route, for 20 we do not have a route. Okay, so let's configure a route for 20. IP route. I want to reach 2110 255.255.255.0. Then instead of next hop address, this time I will give the exit interface. So if router 1, R1, wants to forward the packets to the 20 network, through which interface the packets will exit? Through this interface. Router will send this side, right? So the packets will exit through this interface. Correct? So that means my exit interface will be Z0 by 0. This exit interface will be on the same router only, will not be for the next router. Okay. This is from the same router, that through which interface your router is going to send out the packets. Done. Now check. Again, do show IP route. Do we have a route for 20? But now your router is considering what? Router is considering that this is directly connected because we haven't given next hop address. It will consider directly connected. Now, since this is considering directly connected, and now if I give the ping command, if I say ping 2112, what will happen? Packet will be generated. Router will check how do I reach 2112. It will check in the routing table. Okay, I have a route for 20. How do I reach 20? Through this interface. Directly forward the packets. No need to check twice. So you see the recursive lookup problem is solved. Correct? So see, we'll be able to ping. Do ping. See, the problem is solved. Correct? But still there is a problem. Okay. What is the problem here? The problem here is proxy ARP. What will be the problem? Proxy ARP. See what will happen. When R1 will try to communicate with the 2110, it will send out an ARP because it doesn't know. So it is going to send out ARP. What your router 2 will do? It will put on. It is going to give its own MAC address. Remember, whenever two hosts are separated by a router, then your router in between will be acting as a proxy. Correct? So router will give its own MAC address. Right? Okay. Now, right now, we are able to have communication. Why? Because this router is giving up the MAC address. Right? See, if I will ping 12.2 and this 20, both will have the same MAC address. You see here. This is R2, not R2. On R1, we need. Do show up. If you see the IP 12.2, what is the MAC address? 5901, 2112, 5901. Correct. So both are having the same MAC address, means your router in between is acting as a proxy. But what will happen if this router stop acting as a proxy? Packet will be lost. Packet will be lost. See what will happen. Right now, the router R2 is giving up the MAC address of this interface to this one. Whether it is asking for 20, or even if I configure one same route for 30 also, it will give up for 30 also. Okay. So if this router will not give the MAC address, R1 will never get the MAC address for 20. And if R1 will not get the MAC address for 20 due to encapsulation failure, the packets will drop. Okay. So by default, proxy ARP is enabled in your routers. By default, proxy ARP is enabled. So what I'm going to do right now, I'm going to disable the proxy ARP on this interface because router is giving this interface MAC address. Okay. So on this Z0 by 0, I will disable the proxy ARP. How do you disable the proxy ARP? See. Go to the interface Z0 by 0, and command is no IP proxy ARP. Now proxy ARP on the interface Z0 by 0 on the router R2 is disabled. Okay. So should I be able to communicate or not? No. This is R1. If I say do ping 2112, I'm still able to ping. Why? Because ARP entry is already there. And ARP happens only one time in the beginning. Then the ARP entry is already there, MAC address is already there. So router will not send the ARP again. But if this ARP gets cleared, if this ARP entry gets cleared, if this MAC address gets cleared, then what will happen? It will send ARP, and router 2 is not going to give the MAC address. So let's go and clear the ARP. So how do you clear the ARP? Do clear ARP. No, that is in the PCs. That is in the PC. ARP-D is for the PC. Okay. For the router, do clear ARP. Done. Check again. Do show ARP. Sometimes this command will not work, but right now this is working. Okay. So right now you see we do not have the MAC address for 2112. And do I have a route? Do show IP route. I do not have a ARP entry, but I still have a route. Correct. Now what will happen when I will say 2112? So what your router is going to do? Going to generate ARP, and it will not get the MAC address because router 2 is not acting as a proxy now. So your all packets are going to drop. See, all the packets will drop. Not communicating. Why? Because router 2 is not giving the MAC address. If you see here, do show up no MAC address for 2112. But as soon as your R2 will start acting as a proxy, you will have the communication. We said no IP proxy R. This time to enable it, I'll say IP proxy R. Just remove no. Now it is acting as a proxy. Now try to have the communication. You see? So your proxy ARP is an issue here. It is a disadvantage. So if the router is not acting as a proxy, then you will not have the communication. So what if I try to ping the 10? If you see here, for the 10 network, okay, let me show you. Do show IP route. For the 10 network, I have given the next hop, right? So if I try to see, if I disable proxy ARP on the R2 again, let's say I'll go and disable proxy ARP. No IP proxy. Disabled again. Now if I try to ping 10, will I be able to ping 10? Why? Because this time there will be no proxy ARP, there will be only ARP. Why? Because the router will be generating the ARP for 12.2. Okay. So if router is generating ARP for 12.2, that means this IP address only. So this will be a normal ARP and ARP request and ARP response, not a proxy ARP. Okay. So here we will be able to communicate. If you try to ping, see, to ping 10.1.1, I'll be able to. Okay. All right. Now see. Let me enable the proxy app again. So here we have a disadvantage. What is the disadvantage? Proxy. This is clear.
Sir, I had a little doubt, sir. So in this case, we have two routers, and when we choose exit paired for giga 0/0, but sir, if we have three routers and we have,
Doesn't matter any number of routers. If you have,
but it will show direct connect or not.
yeah, it will show you directly connected. See, let's say if you have one more router here, this will be Z0/1. This will be again Z0/0. Again, if you are going, so exit interface will be this only. So if you are giving this interface, that means router will always consider it directly connected. That's why this type of static route is known as directly connected static route. Okay. So doesn't matter it is beyond 2 routers, 3 routers, 10 routers, or 100 routers. The concept will remain the same. Okay. Same thing is with the next hop also. If your networks are 10 routers beyond, 100 routers beyond, still your next hop will be the next router only. Okay. It will not make any difference. This is clear. So now you saw that in case of, if you are going with the Lux, for example, if I'm using recursive static route, is your proxy ARP affecting here? No. So means the solution to this problem is first one, right? And the solution to this one is this one. Because here we do not have recursive lookup. Only one time lookup is there. But still proxy ARP is a problem. And since proxy ARP is a problem here, that problem is not there in the first part. Now what to do?
There should be mixture.
There should be mixture, right? Because ultimately, what is happening? The solution to the problem of the second person is with the first person, and first person problem solution is with the second person. So they both have solution to each other's problem. So what to do? Mix them up. Yes, means this time we are going to define both the things, next hop as well as exit interface. So next stop will remove the problem of proxy R. Exit interface will remove the problem of your recursive lookup. And we will get our best way to configure your static route. Okay.
Sir, recursive lookup only happens only in case of static route or also happens in case of dynamic route.
No, it will not happen in case of dynamic route. Okay. So then third we have fully specified static route. And this is the one that you actually configure in the enterprise production environment. Okay. Now see how you are going to configure IP route. Again, the destination network. Then the subnet mask of the destination. Then always first your exit interface will come. Okay, your next stop will not come first. First your exit interface will come. And after that, you will configure next stop. If you try to configure next stop first and then exit interface, you will get an error. Okay, that invalid input detected.
Is the read well slow?
No, it's not about the ED value, but this it is the syntax of the command. Okay, this is how the command is defined. We cannot use exit interface after the next stop. Okay, and this is your best way to configure static route. Okay, this is the one you will actually be using in the production node. Now this thing is not supported in the packet tracer. Okay, if you want to practice this thing, you can directly go to the lab and practice. Okay, and the real routers, this will be perfectly working. Okay, all right. So then how we are going to do the practice for this, right? So here in the packet tracer, we will not be able to do the practice. Either you have to use GNS3 or evenG. Okay. So let me go and use evenG. See, this is our lab. The same topology I'll design here. Let's say these are 1.1. Okay, let me start the routers. And let me copy the configuration because this is the configuration we have done. Same configuration will be there. So in the packet, in the evenG and GNS3, you use the real router IOs. Okay, they will be simulating like the real routers. So these will take some time to come up. This is R1. This one is R. You can see here R1 and here R2. Okay. Packet tracer routers work really fast, right? But here real routers, they will work a bit slower than that. Means in the booting time, in packet tracer, they will instantly come up.
This one occupy the system.
Yes,
That's why
they will occupy the system resources like all the CPU, RAM, everything they'll occupy from the system itself. Okay, right now, each and every router, they are using 1 GB of RAM. Okay. System configuration dialog, because no configuration is there. And the same thing, the routers, when they started, we saw in the lab also. Same set of things. No, that is a part of your CCIE. But there are certain videos available on YouTube, you can check. Because in the class, if I will take it, will take up some time. You have to download it and then install it. Actually, main thing is like not the downloading and configuration, but the main part is in these routers, switches, these things will not be available by default. You have to separately install all the routers and images for the switches and all. I use. Okay. So these things will by default not available. Okay, this is R1. Let's copy the configuration for R1. R1 configuration is done. R2. Okay. You can check the interfaces are Z0 by 0, Z0 by 0. Okay. Now let me do one. Okay, let me do one thing. Let me change the color so you can easily identify R1 and R2. So for R1, we'll keep the color to be, and for R2, we'll keep the color to red. Okay. So R1, R2, we have. So if you check the routes, do show IP route. The same things will be available with the C port 12.0, IP 12.1. Okay. Now let's configure the static route we are trying to configure. So you have to say IP route. Then you will give the destination network, let's say 10.1.1.0, 255.255.255.0. Correct. Then after we have to give the exit interface. So what will be the exit interface? Z0 by 0. Z0 by 0. Okay. And then I can give the next hop address 192.168.12. If you see, if I'm giving here Z0 by 0, after that, okay, right now it is considering. See, when you use question mark in some other mode, question mark will not work, command will work. Okay. So let me do one thing. IP route 10.1.1.0, 255.255.255.0. And if I give here Z0 by 0, after that I have the option, right, to give forwarding router's address. That is your next hop address. Okay. But if I give the next hop address first, 192.168.12.2, do I have anything related to interface here? No, you will not get the option. Okay. And here you will get both the options for exit interface and everything. See, you guys see, you're getting which interface. Okay. So say Z 0 by 0, then the next hop address 192.168.12.2. Done. Now if you check the route, do show IP route. Okay. Check. We have the route. AD value is 1 via 12.2 and also the interface Z0 by 0. Both things will be mentioned. So when you try to ping, let's say you give the command ping 10.1.1.2. Now what will happen? It will check for the routing table. When it is checking, it will check, okay, I have to go, I have a route for 10 and I can reach via 12.2. But also I know the exit interface through which interface I have to forward the packet. Means this 12.2 is available on this interface. Right? So this is how your router will check only one time. And if the proxy ARP will be disabled, you already know that, okay, how you're going to go via 12.2. So you will generate an ARP only for 12.2 on the interface Z0 by 0. So proxy ARP will also not create a problem. Okay. This is how you are going to define. If the same command I try to use in the packet tracer, check. Packet tracer does not support. Let me go to our to show IP route. Okay, for 30, I'm not having a route. So here I try to create a route for 30. 255, 255, 2550, then exit interface, then see invalid input detect. So packet tracer will not support this. Okay. This is clear. Okay. Now next type of route. Floating static route. This is the route where you change the AD value. Okay, by default, AD is what? 1. Okay. So here, how you're going to change the AD value? You'll say IP route. Okay, so if you check this command right now, if I'm giving, let's say Z0 by 0 or anything, so I have a only option for changing the metric. Okay, now see IP route. Again, you will say network. And then after you will give subnet mask. And then let's say you will give whatever you want to give. But in the actual scenarios, you will always be using both the things, exit interface and next hop address. Okay, so now onwards, I'll just type in both. Exit interface, next hop. And after that, you're going to type AD value. Okay. The administrative distance value. What you want to change. Now, how this is going to work. Okay. So consider a scenario. Let me directly create the lab itself. R1 is there, R2 is there. In the same lab only, I will do some modifications. I'll add in one more router. And this router, I'll call it as R3. Okay. And then I'll make the connections. Now clear that here we are using 12.0 network. Now since this is R1 and R3, so I will use 13.0 and this is R2 and R3, so 23.0. Okay. Like with the number of the routers only we will use the network. And this side we'll use 23.0/20. Okay. On R2, we will have all IPs .2. On R3, we will have all IPs .3 and here all IPs .1. Okay. That means 13.1, here 13.3, 23.3, 23.2. Okay. Okay, so let's type configuration for R3. Okay, similar kind of configuration will be there. R3. Then R3. This will be 13.3. Correct. This will be Z0/1. This will be 23.3. Done. Any other configuration or R3 required? No. Okay. Copy. CLI. No. Enable. Paste. Done. Okay. Since this is R3, so R3 also should know how to reach these networks. Okay. R3 should know how to reach these networks. So what I'll do, I'll create a default route on R3 for these networks. Okay. I'll say IP route. Then I will say 10 dot. Sorry. How do we create a default route? Then next stop 192.168.23. Done. Sorry, 23.2. Okay, see, it is saying it's this router. Okay. Okay, R3 knows how to reach this network. R1 knows how to reach these networks. Okay. So on R1, I have already defined a route for 10. If you see, do show IP route. Okay. One more thing, we have to attach the IP addresses. IP addresses on these. On R1 and R2 also. So interface Z0/1, the IP address on R1 will be 13.1.
Yes, sir.
And then no shutdown. It is a similarly on R2 also we have to set the IP address. Interface Z0/1 IP address 23.2 on R2, right? Done. Okay. Now if I check on R1, so on R1 I already have a route. I already have a route for 10, 20, and 30. Correct? Okay. Now what I'll do? For 10, I have a route via 12.2, going directly from here to here. But I want that in case if this link goes down, then what I need to do? I need to follow this path. So I want to configure a backup path. Okay. So for configuring a backup path, what I'll do? I'll say IP route. Okay. Then what will happen? Which network I want to reach? 10.1.1.0, 255.255.255.0. And let's say I'm giving 192.168.13.3. Next one. I'm trying to configure this side. If I do not change the metric, what will happen? Both will have the same metric, means same ID value 1. So router will consider both as the best path. Then router will start forwarding one packet this side, one packet this side, again one packet this side, one packet this side. Now, if you see, this is a longer path, right? Okay, so there can be like some packets are reaching, some are not reaching, or delayed reaching. These kind of situations can be there, right? So to avoid this, what we'll do, we are configuring it as a backup path, that this path should only be used when this path is down. So we will change the metric. How do you change the metric? After the next stop exit interface, just give metric 2, 5, 10, whatever you want to give. Okay, let's say I'll make it 5. Okay, see, the command will be network mask exit interface next stop and then AD value.
If I give the ID value of OSP.
Anything you can give, that is up to you. I'm saying anything. Okay, you can see. Okay, right now we are in the interface configuration, so it will not show you, but anything you can give here. The AD value is 0 to 255. You can give anything, up to you. Okay, so let's say I'll make it 5. Hit enter.
If we take the lowest.
Yes, so by default it will keep this route only,
Yeah, because it is 0.
because since in the routing table there is only the best route, no other routes will be available. So if you check the routing table, now sometimes you'll get confused that okay, I already configured the router, but I'm still not seeing it in the routing table. Why not seeing? Because in the routing table only best routes are available. Okay. Now what? If you see R1 will try to forward the packets. Okay. But one more thing, if I'm trying to configure this way, when this path is down, so that means I have to tell R2 also that when this path is down, start forwarding this side, right? So what I'll do here, I'll configure a default route. Okay, you can configure a static route also. Right now I'll configure default route this side. So I'll say IP route. Then what will be the next route? 23.3. R3 will be the next route. Done. Now check. From here, if I say ping 10.1.1.2, do ping. I'm able to ping, but are we able to know on which path, through which path the packets are going? No. So what we can do, we can trace route here. Okay. Remember the trace route command will tell which router it is taking to forward the packet. Right. So I'll say trace route 10.1.1.2. Directly going to 12.2. Right. So what I'll do now, I will shut down this interface. Okay. So right now this interface is up. So in the routing table, you are seeing via 12.8. Now let me shut down the interface. So I'll say interface, not here. Global configuration mode, interface the 0x0. And I'll say shut down. That interface is down now. Just check the routing table. Show IP route. Automatically your floating static route will come into the picture. Okay, having the AD value of 5, going via 13.3. Still, if you check the connectivity, sorry, 10.1.1.2, you will have the connectivity. See? You have the connectivity, and if you want to check through which path it is going, so you already know in the route, but still.
If that link is going up, means
Again, that will come back up. Small AD, lowest AD, it will
take
automatic. See, first going to 13.3, then going to 23.2. Okay. And as soon as this link coming back up, okay, right now check, do show IP route. Show IP route. Going via 13.3. As soon as the link will come up. Okay, interface is 0x0 and no shut. Do show IP route. It is back up. Okay. Is that clear? Floating static route is clear.
Actually, if we try to configure reverse stuff,
Reverse.
means we have to give a command to the desktop of R1 gigabyte 0/1
Hmm.
and on R3 gigabyte 0/1.
Hmm.
That time we don't require default route.
No, that is up to you. How you want to configure.
We can give default or static.
Yes.
Both we will do.
You see, usually you will give static in case you have more than one interface to reach. In that case, you will give static route on. Right now, I used this. I mean, I use default route. Why? Because when R3 wants to communicate with R1, this thing is already directly connected. And this side beyond R1, we do not have any route. That was the reason. So that's why I use default. Otherwise, if you have more than one path, most probably you will configure static only. Okay. And static, if the network is large, we will not even use static. We'll go with the dynamic routes. Okay. And dynamic routes will do all these calculations, how to reach, how not to reach, what will be the backup path, and all these calculations they will do automatically. We don't have to do anything. Okay. This is clear?
Sir, what's it?
Yes.
So for example, our procedure is R1 to R2.
Hmm.
If it is down, we start communicating from R2 to R3. But suddenly our root buster up, what will happen?
Right now we saw right the same thing.
The AD.
The AD value, lowest AD value automatically coming back up. You see that? Going back again via 12.2, directly going to R2. Okay. The same thing we saw. Router will always prefer the lowest AD only. Okay. This is clear. Okay.
And so one thing more, if we in default routing, it will put it exit gate, will it work? Or-
Yes, it will work. See, default is what? Same as static only. It's just a special case. So you can see in that if you are configuring default also, you will be using both the things, exit interface as well as next hop. The best way only. Okay, we will not use like only next hop or only exit interface. Right now in the packet tracer, I'm using because it is not supporting here. Okay.
That one thing more
Mhm.
is trace route and show IP route and then IP address same.
No, they are not the same. Trace route is to check the between source and destination. If I'm sending packet from here to here, which path it is taking, either taking this path or this path. So in this path, I do not have any router, so it directly gave me the 12.2 IP. And when the packets were coming through it, it said 13.3, then 23.2. So it will tell you exactly which path your data is taking to reach the destination. Okay. Because in the real routers, we don't have the simulation mode and we can go and check, okay, through which path the packet is traveling. That things we cannot do. Okay. This is clear. Next we have host route. Host route is what? When you are configuring a route for a particular IP, just a single host, that is a host route. Okay. So in host route, what you'll be doing? Here you will give the host IP address, the system you want to reach. Then the subnet mask will be all 255 because single IP we are trying to reach. And then you have to give the exit interface and next hop address. Okay. These are the things. So the things are similar only small changes we are making sometimes for a single IP, sometimes for a entire network, sometimes changing the AD value, sometimes using the only next hop and sometimes exit interface. Okay. But this will always be the best way. This one. Okay. Now these are the things like host route and floating static route. These are on the requirement basis. Like in what case you will be using host routes usually. Let's say you want that That can be anything, but see, usually how you will be using, you want that, okay, your entire traffic for the network should pass through this path. But for a particular server, the traffic should take this way. So that if someone is sniffing the traffic on this path, they will not come to know the server traffic. Okay, this kind of thing. So means what you will be usually doing, let's say you have configured one route for entire network through 12.2. Then what you will do, you will configure one specific route for the IP. Let's say, for example, IP route 10.1.1.2 255.255.255.255 and go via 192.168.13.3. Okay. Now see. Do you see? For entire network, you have a route via 12.2. And for a specific IP, you have a route via. Now what will happen? Whenever you try to go to this IP, your router will always choose this path. Okay.
So
And-
for a particular IP address, we always use that 32.
Yes, because block size is 1. Right? If you try to configure something like this, let's say IP route. Okay, then 192.1, that's it, 20.1.1.2. And then if you try to give like this. Okay, let's say 192.168.13.3. Your router will not let you configure. Why? Because this is a single IP. So your address and mask will be inconsistent, not matching. Okay. Any doubt in the types of static route? No? Okay. So types of static route or the ways to configure static route, they are clear. Right? Okay.